Hello everyone, today in this video we'll be discussing the last preparation methods for saturated hydrocarbons, that is alkanes. In the previous videos we have discussed the first two preparation methods, that is, the first one is hydrogenation of unsaturated hydrocarbons and the second one was from alkyl halides. Now the third preparation method is from carboxylic acids. In these preparation methods from carboxylic acids, salts of carboxylic acids is taken to get our product, that is our saturated hydrocarbons known as alkanes. Therefore, from carboxylic acids, the first reaction from carboxylic acids will be our decarboxylation reaction. Decarboxylation reaction, in this reaction the name itself says decarboxylation, therefore it will be the removal of carbon dioxide. Here salts of carboxylic acids are used, therefore salts of carboxylic acid, a typical example would be this. When it in a basic medium, that is sodium hydroxide plus CaO, when salts of carboxylic acid react with NaOH, sodium hydroxide and CaO. These two, they are known as soda lime. When the salts of carboxylic acid reacts with soda lime on heating, we get our saturated hydrocarbons with the removal of Na2CO3, and this is known as sodium carbonate. Here there is removal of all this is removed, Na2 and then CO3 is removed here, and then there is formation of our alkane molecule here. Therefore this is known as decarboxylation reaction. An example here is CH3COO, Na negative, positive negative. When it reacts with soda lime, that is NaOH plus CaO, is known as calcium oxide and sodium hydroxide. Together when they react, they are known as soda lime. On heating, we get our CH4, methane, and Na2CO3. Now, one point to be noted here is the alkanes form contains one carbon less than the carboxylic acid. Now from here, condition here is that the alkanes form contains one carbon less than the carboxylic acid. Therefore from here it can be known that the carboxylic acid alkanes, here there are two carbon atoms here in the salt of our carboxylic acid, but in the product form we have only one carbon atom here. Therefore the product form, our alkane form, would have one carbon atom less than our starting salt of the carboxylic acid. Therefore this is known as decarboxylation reaction of salts of carboxylic acids for the preparation of saturated hydrocarbons, that is, it would be our alkanes. Now the second method is known as Kolbe's electrolytic reaction. Now in Kolbe's electrolytic reaction, a medium is taken. A medium is taken where there is cathode and anode. Plug in, and then in a medium solution of the salt of our carboxylic acid. Here the salt is taken in aqueous medium. In aqueous medium, then this is our anode and this will be our cathode, positive, negative. Now in Kolbe's electrolytic reaction, the reaction takes place here. R COO minus Na plus, here water on electrolysis, therefore water reacts here. HOH, water can be written in this form, H2O, and then on electrolysis, when electrolysis means electric current is passed, we get our alkane here with the removal of CO2 and then NaOH and hydrogen gas is released here. Now in this reaction, 2 moles of the salt of the carboxylic acid is taken with 2 moles of water, and then here our product here would be 2 CO2 and 2 NaOH, because we need an alkane here. Therefore, an example, let's take an example here. 2 molecules of CH3CONA, this is sodium acetate. On electrolysis with water, CH3, since there are 2 molecules of sodium acetate, the 2 molecules of acetate will join here, CH3, with the removal of 2 molecules of carbon dioxide. This will be removed from both the molecules of sodium acetate, and then 2 molecules of NaOH, and evolution of hydrogen gas takes place. Now, the point to be given, and when our starting product is a methyl group, then the product here will be 2 carbon atoms more, because 2 moles of this is used. And if our starting product is this, then starting reagent is this, then our product would be, the alkane form would be this, because 2 moles each of both is used. Therefore, the starting product would be 1 carbon atom more than the starting carbon atom, starting carbon molecule. Now, here there is a mechanism in this reaction, is that at anode. Now, what reactions takes place as anode and cathode? Now, the reaction that takes place in this reaction is, now let us check what reactions takes place at anode. Now at anode, the 2 molecules of the salt of the carboxylic acid, if we take sodium acetate, carbon has the lone pairs, the negative charge. Therefore, now this when it reacts, this bond breaks up, 1 electron goes here, and then 1 electron goes here individually. Therefore, there is formation of a free radical is formed along with the carbon dioxide. This is supported by entropy. Therefore, whatever entropy is supported, it will be, with the compound itself will be very stable. With the removal of, there will be removal of carbon dioxide is removed. Now, since now there are 2 molecules of the CH3 methyl radical, therefore the 2 molecules of methyl radical, the 2 methyl radicals each share the electrons to form a bond, and therefore there is formation of our alkane here. Now, therefore, at anode, our alkane is formed. Now, question arises here. At Kolbe's electrolytic reaction of preparation of saturated hydrocarbons, what happens at anode? Therefore, it is to be noted that at anode, carbon dioxide is also released, but the main reaction that occurs here is at anode, our alkane is formed. Now, what happens at cathode? Now, at cathode, the sodium ions on hydrolysis, there is release of hydrogen gas is released in this reaction, because, and in solution we have OH minus, the OH minus goes and takes up this, and then the reaction takes place on electrolysis, and there is removal of hydrogen gas. Therefore, at anode, hydrogen gas is formed. That means we know that H plus is released in the solution. Therefore, this H plus goes to the cathode, and there is formation of H2, and at anode there is formation of our ethane molecule, that is our saturated hydrocarbon known as ethane is formed. Therefore, this is the reaction preparation methods, the 3 preparation methods. In the first video I've discussed the first 2, that is, the first one is hydrogenation of unsaturated hydrocarbons, and the second one is from alkyl halides, and then this is our 3rd preparation, that is decarbox from carboxylic acids, where the sub reaction is from by decarboxylation, and then Kolbe's electrolytic reaction method. So therefore, these are the preparation methods for alkanes.